Hey there, everybody. Welcome back. This is 14.3, Calculus 3. We're working in polar coordinates for double integrals. Let's take a look at when we've got weird regions and how we set up those limits. So for this example, we're going to do a region outside the circle, r equals 2, centered at the origin, and inside the circle, r equals 4 cosine theta, which is a circle centered at 2, 0, with a radius of 2. I have a picture of it over here. And so we are looking at this region over here between the red line and this blue line over here. Okay. And I drew that here. And so to find where, like, I need to know my limits of integration. I'm clearly, when I do R, I'm going across both. The first R I'm going across is the R equals 2 line. The second R I'm going across is the R equals 4 cosine theta line. To find the intersections, I set R1 and R2 equals to each other. So 2 equals 4 cosine 2 theta. We solve for theta, we get theta equals negative pi over 3 and pi over 3, which is here and here. So my region is now from 2 to R to 4 cosine theta, and negative pi over 3 to theta to pi over 3. So we start here, and we're sweeping the angle that way, all the way up to there. Okay. What that changes our integral. That's just set up our integral. We didn't have a function. Again, don't ever forget your r d theta. What if we wanted the inner area where they overlap? Like right here. I wanted to show that this is actually 3 regions. So if I turn on these lines right here, and let's see, I start at negative. Right here, notice that the radius goes from 0 to 4 cosine theta. The blue circle is 4 cosine theta. And then I get to a region where I'm going from 0 to 2. And when I get high enough, I'm now going from 0 to 4 cosine theta again. So this is going to be 3 different integrals to get this middle range in polar. Okay. So this is what I had in Desmos. For region 3, the bottom one, we're going from negative pi over 2 to negative pi over 3, because we already figured out the overlap, negative pi over 3 and pi over 3. R equals 0 to 4 cosine theta. That's what we said earlier. When we get to region 2, we're doing, it's negative pi over 3 to pi over 3, and R is 0 to 2. And when we're doing the top region, again, this is going from pi over 3 to pi over 2, straight vertical. And R equals 0 back to 4 cosine theta again. We set up our triple integral, or not triple integral, we set up our double integral for each region. And depending on the function, we evaluate, again, not forgetting that each one needs r d theta. The R is the easiest part to forget. That's it for this section, or this part. We'll do an example in the next video. Peace.